Momentum is a fundamental concept in physics that describes an object's resistance to changes in its motion. Think of it as a measure of how difficult it is to stop a moving object. More precisely, momentum, often denoted by the symbol p, is defined as the product of an object's mass and its velocity. The formula for momentum is p equals m times v. A heavier object moving at the same velocity will have more momentum than a lighter one. Let's see this in action. Similarly, an object moving at a higher velocity will have more momentum than the same object moving slower. Momentum is a vector quantity, meaning it has both magnitude and direction. The direction of the momentum is the same as the direction of the object's velocity. The standard unit for momentum is kilogram meters per second, abbreviated as km per sec. This unit comes directly from the formula P equals m times v. Momentum is not always constant. When forces act on objects over time, momentum can change. This change in momentum is called impulse. Consider an object with initial momentum, represented by this vector. The length shows the magnitude, and the direction shows the direction of motion. When a force acts on this object for a specific time interval, it creates what we call impulse. Let's define impulse mathematically. Impulse, denoted by J, equals force multiplied by the time interval over which the force acts. This is the fundamental equation for impulse, J equals F times delta T. The impulse-momentum theorem is one of the most important relationships in physics. It states that impulse equals the change in momentum. Since impulse equals F times delta T and change in momentum equals mass times change in velocity, we can write the complete relationship. This gives us F times delta T equals m times delta V, where delta V is the change in velocity. Let's see this in action with a visual demonstration of how force and time affect momentum change. Here we see an object before and after an impact. The momentum vector changes both in magnitude and direction due to the impulse. This principle applies to many real-world situations. In car crashes, the force during collision and the duration of impact determine the change in the car's momentum. Safety features like crumple zones work by increasing the time of collision, which reduces the force for the same change in momentum. In sports, the same principle applies. When a bat hits a baseball, the force and contact time determine how the ball's momentum changes. Understanding impulse helps us analyze and predict the outcomes of collisions and impacts in both everyday life and engineering applications. Remember the key relationship. Impulse equals the change in momentum, which gives us powerful tools for analyzing motion and forces.